gói tiên tiến cũng như những cơ hội dành cho Việt Nam và Đà Nẵng. Và tiếp theo chương trình, hội thảo sẽ chuyển sang một trong những chủ đề then chốt của ngành bán dẫn hiện nay, kiến trúc của đổi mới sáng tạo và vai trò quan trọng của công nghệ đóng gói tiên tiến. Khi tiến trình thu nhỏ transistor dần chạm ngưỡng giới hạn vật lý, đóng gói tiên tiến chính là chìa khóa mở ra chặng đường phát triển tiếp theo của toàn ngành. Và diễn giả tiếp theo là người đã trực tiếp dẫn dắt lĩnh vực này tại những tập đoàn công nghệ hàng đầu thế giới. Xin được trân trọng kính mời tiến sĩ Babak Sabi, cố vấn kỹ thuật, nguyên phó chủ tịch Amazon và phó chủ tịch cấp cao Intel sẽ trình bày tham luận với chủ đề kiến trúc của đổi mới, vì sao đóng gói tiên tiến quan trọng vào lúc này. Xin được trân trọng kính mời ông.
Good afternoon. Can you hear me okay? All right. Well, this is my first time in Da Nang, and I got to say that it's a beautiful city. I should have come here earlier, but at any rate, what I want to do is really a follow-up to the previous presentation and really trying to explain why advanced packaging now? Why is it so important? And if you look at the picture I have shown here, is that I have shown you a rack of AI at Amazon. And this is how this rack looks like. A lot of wires, a lot of silicon in there, a lot of packages. So each of these racks are millions of dollars worth of material in there. So I want to take a big overview where the semiconductor industry has been and where it's going to. Oops. All right, so there are 3 eras, and by the way, I have been present in each of these eras here, so I've been around for a long time. So the first era is what we call vertical integration. There were big companies like IBM, like Cray, Digital Equipment Corporation, if some of you remember those companies at the time. And they were completely vertically orientated. They did their own silicon, they did their own packaging, they did their own software, they built their own systems, and they sold into the market here. That era sort of ended when personal computer came about. And we went to what I call the horizontal disruption, where not all of these companies could afford to do their own silicon development, to do their own package development. So we ended up having the era for, some of us remember, we used to call it Wintel. By the way, I love the era because I was at Intel at the time, and it was quite lucrative, and it was really, we made a lot of changes in the industry. And this is where you would buy components, and then there were a whole bunch of system integrators that would buy the components from Intel, AMD. They used software from Microsoft or somebody else, and they put a system together. And most of the money was made by the software companies and the component providers like Intel, AMD, etc. And in the last 5 or 6 years, there has been a revolution. With the advent of AI and the rise of data centers, we're back into vertical, but not quite the exact same way. These companies like Amazon, Google, Microsoft, Facebook, etc., they basically design their own chips now, and I'll explain that to you in a second, but they rely very heavily on foundries like TSMC or Samsung, and hopefully in future on Intel, and then they use OSATs. So I think it's very important for Vietnam, a semiconductor industry, to understand who the customers are. The main customers are the data center people in future. So that's where you want to be focused on your future customers here. And and the reason that they built their own chip is that they know exactly what their customers want. So they know what the workload is. They can actually optimize the workload, and they really gain significant generation-to-generation performance lead, something that you couldn't get if you would buy chips from Intel or AMD or somebody else. So each of these companies, like AWS, Huawei, Google, they are all designing their own chips now. And they rely on foundries and OSATs and other people to do the development and manufacturing for them. So the whole industry, as we saw in the previous presentation by Chairman Ye, that is driven by AI. Things have accelerated quite significantly since the advent of AI. And as you could see, and I will show you some graphs that you could actually see that. The reason is that in order for us to have intelligence, we need to have significant computing power. Significant computing power. And so there's this term that is called scale up, which is that you want to have the most advanced semiconductor component that you could potentially build, put as much silicon and memory into this package as you can fit, and then put them in data centers. And you want to connect all the data centers together, because each time that you try to do a training of, let's say, the latest chat GPT, you need sometimes 1 million, sometimes 2 million chips working together at the same time. So you want all the data centers to be connected together. So that's where you get a lot of optics coming into play here as well also. So what does this mean? The technology scaling, which people talk about, Moore's Law, it's been around for 50 plus years. And every 18 months to 2 years, you basically double density and you put more transistor there. And this has been going on for many, many generations. And there are often people have said that the Moore's Law is coming to an end. So far it hasn't. There has been enough invention across the industry. So Moore's Law has continued to move on. It's getting harder. It's getting a lot more expensive to do it. But as you can see from this graph here, we have been able to keep adding more and more transistors in the same unit area here. So why can't we make the chips bigger? And this has to do with the size, how big we can print the chip. I have a very, very boring graph here. It's just a flat line. The size of the chip has been fairly constant, around 830 millimeters square, for as many generations as you can get it. It hasn't changed one bit. If you go talk to ASML, that they're making the latest EUV lithography tool today, nobody is going to go beyond this limit. And there are many practical reasons for not doing that, and it's mostly economics. You can make bigger and bigger chips, but it won't yield. You won't be able to make anything. So the size of the chip is basically hasn't changed, and it won't change. It stays at 830 millimeters square. If you look at what I had shown you before, is that we want to stuff more and more silicon into each of these packages. So how do we go about doing this? This is exactly what the architects do. You're trying to build a city, you're running out of real estate, so you make skyscrapers. And this is exactly this whole chiplet technology that was getting described before. This is what people are doing. They're making skyscrapers, and in order to make the connections, the bridges between the chips here, and you can see you have high-speed connection, we call them bridges. So it's the same thing as you do in a big modern city. You build a lot of skyscrapers, and the TSVs that were discussed previously, they're like elevators. They're like elevator shafts that take information up and down into various floors that you have there. So this is why advanced packaging is becoming more and more important here. I mean, your silicon is the same size, 830 millimeters square. The best you can do is every 2 years to make it 2x better. But with advanced packaging, I can make it 10x better. So that's why advanced packaging is becoming so important to the industry here. And I want to give you a little bit of a vision of how these AI chips are going to look like in future. Today, we make the package substrate on a panel. A panel is about 0.5 meter by 0.5 meter per side. It's much bigger than a silicon wafer, which is around 300 millimeters square. Within 3 to 4 years, we're going to see packages that they're going to be a quarter of a panel. And you're going to put a lot of silicon and memory in there. You're going to have co-packaged optics because you want to be able to connect as many of these chips together at the lowest latency, at the fastest speed that you can. So there's going to be a lot of optics in there. And if you look at a package like this, my best estimate is that by the time you make it, it's going to be about somewhere between $300,000 to $400,000 worth of material in each one of these packages. For those of you who are car fanatics, this is half a Ferrari in just one of these packages here. So there's big money involved in this. And these packages are going to be put on a board. We put connectors on the backside of it, and you integrate a lot of other components on the backside of this package. So, and then you insert that into your main board to make your AI motherboard. And each of those AI motherboards is going to be close to about $3 to $4 million per board worth of material in it. I mean, so this industry is getting big and bigger. Just to reiterate that, I mean, you can see that this is the size of the same graph was shown previously, and I was at a conference about 2 weeks ago, and SEMI has also made the latest prediction that we could see the size of the semi industry going over $2 trillion by the end of this decade here. I mean, there's a big range there, somewhere between 1.1 to $2 trillion. I mean, this is a massive growth that we have. And a lot of this growth is also driven by advanced packaging. What I showed you before in the vision of the package that we're going to see 3 or 4 years from now, the area of the package is going to grow significantly. So the capacity that is going to be needed to build the future AI is going to be quite significant. So there's a lot of business here. And this is why advanced packaging makes a lot of sense to get into. There will be huge, huge demand for advanced packaging to build this future AI chips here. So the future is really going to be fueled by advanced packaging, and AI is going to drive capacity here. I mean, that's why if you look at all the packaging companies, they're adding factories like crazy. Same thing is happening with memory companies. So we can argue that is there a bubble here? It could be a short-term bubble, but if you look at this thing long-term, it's not going to be a bubble. This is going to be something that we will need. So don't get too scared because of the current bubble here. And I actually think that VSAP is really positioned well to take advantage of this unbelievable growth that we're going to experience here. So I think the timing is right. Vietnam is the right place to do this. I mean, I have been involved with Vietnam because I was at Intel, and I helped to transfer technology to Intel Vietnam factory in 2009. So I think we have the talent, we have the workforce, and I think this is really a great thing for Vietnam for future. Thank you.